So in this video, I will explain some performance tricks that you can apply to your game and to improve the performance. Especially if it's casual, you would like to reach a lot of people. In order to achieve that, your game needs to perform good with basically on all devices. And anyways, that's the idea. And now I'll start with collisions. We use Play Canvas, and Play Canvas offers this physics engine called MOJS. It's nice, but first of all, it loads 1 MB, and especially on web gaming, you would like to have smallest game possible. Since that's the case, first of all, we cannot load 1 MB physics library for just simple collisions. On this game, collisions are super simple. You shouldn't go through a wall. That's it. And there are so many ways to do that. But what I did is basically implement the sphere-based collision. It's a 2D collision. For most cases, for most casual games, you don't even need like 3D world collisions. What you can do is basically do simple 2D collisions. I can explain this in details, but I'll just show you the basic idea of sphere collision. What you do is basically, let me show you, where is this file? Yes, collision. So I get the positions of the spheres, and I basically calculate the radius of them and then apply backward force to player so it doesn't go through the radius. It's really simple, and it doesn't require a lot of CPU, especially on mobile devices. It's the best method you can have. I mean, you can probably do different type of collisions, but that was the first idea that I come up with, and it worked pretty well. So try to not load huge physics engine if you don't need to. You can basically write your own simple collision methods if it's easy for you to do that. Yeah, that was first. And then second, this was really shocking to me, but apparently Phong materials are performing so much better than physical based shaders. I think the main reason whenever you have light, that light's position is being calculated in the material itself, and that basically adds a lot of extra calculations on materials. So how we can do is on Play Canvas, basically there's this option for shading, and then you can change it from physical to Phong. And what you can do also, disable specular. That also takes the lighting information. So I set it to black. For some reason, whenever you set it to black, it doesn't work on Play Canvas, which is nice. This is what I want. That one is simple, but there's another additional detail to this one. If you don't need lighting, don't use lighting, basically. Whenever you have lighting, it also adds a lot of extra calculations. Maybe you don't need lighting, you can just disable it. I mean, as you can see, it doesn't change that much. Probably I can, get some better feeling. But I think whenever you disable specular and also have just one lighting, it's probably fine. Specular adds this different type of calculation on material. So if you disable specular and make it Phong, you can probably get a nice performance boost, but also a little bit, shading on materials like this. As you can see, this is dark, this is more bright. This one is also important on web. Don't load everything, basically just load whatever you need to just show the first frame. Most stuff in the scene can be loaded later. This is what we do, and load the game instantly, basically, and rest of the game basically shows up later. I don't really need to load the burger itself or the customers or even tables, because I don't need them on the first scene. What I need just cash machine, this stuff, that stuff, and stuff like this. So You can basically do that with just clicking on entity on play canvas and then disable preload. Whenever you do that, play canvas basically don't load them unless they are being used on the scene. This one that I'm still working on, but there are super smart ways to do terrains or different type of materials. So in this new game that I'm working on, we have this ground. We would like to make it look good enough, and that was a little bit tricky, but it's possible. So as you can see, we have this terrain, and it's has grass, and it has road, and it has water and everything. This can be a little bit tricky, especially if you add like alpha opacity, like a material that has alpha channels. And we didn't want to do that. Instead, we created this texture, and that's just basically a plane, and we have this shader code on it. I'll show you the shader code as well. With this shader code, basically we just take few textures, really simple textures like this, and then use it again and again to draw the grass, draw the roads and stuff like that. It doesn't have alpha channel, which is nice, and then you can basically warp the textures however you want. And this is just one big plane with simple texture on it, and it doesn't reflect lights, so it's nice, and it works well on mobile, and it looks nice too, like water and all of this stuff. So you can be smart with shaders, and then you don't need to add a lot of details on the objects. You can just come up with smart ideas to warp the textures and use the same texture again and again, stuff like that. Anyways, no shadows. This is really important because so shadows usually works like this on games. You have camera, right? And then camera sees the scene, but you also have light, right? Light source, and light source is also a camera. So whenever you add a light source with shadows, this is also a camera. This camera basically renders the scene, right? And then what it does, takes this texture buffer and create the shadows with this, what it sees basically. And that means whenever you add real-time shadows, even shadows that is being updated time to time, it will add extra camera to the scene, and you can actually see that on Profiler as well. So instead of this, we come up with the smart textures. Well, textures like this is a shadow, and it's just an image, right? I'm sorry. So this is an image, and it has like an opacity and a color on it. And then with that, we can actually even remove this. So we don't need to add shadows into our scene. We can just basically add it around objects like this. So we don't need like full shadows of this character. We can just add this simple shadow to the bottoms, and then we can apply that to everywhere basically. And I actually talked about lighting. So no lighting was part of the no shadows thing. You can have lighting, but it should be simple, and it should be static, and it should be it shouldn't cast shadows. And you can also be smart with layers. You can reflect layer into certain objects. Play Canvas has this feature, layers. So maybe not all objects needs lighting, so you can adjust that if needed. No particles. This one is interesting. I think this might be something that Play Canvas has. I don't know. This one is like we had this particle here, and whenever we enable or disable it or even play it, that was causing some issues on mobile devices. And once we remove it, we see a little bit increase on user engagement. And I believe this is somehow it's tricky one, right? So you would like to you wouldn't want to create a lot of mesh with JavaScript code, I guess. Whenever you do that, it causes frame drops. So don't use particles basically. And no dependencies plugins, this one is like to decrease the amount of you know, you wouldn't want to load a lot of different libraries into your game. If it's possible, just write your simple functions, you know, like you don't really need to load a lot of stuff. You can just basically put all the functions you need in order to make the game smaller on web. And decrease alpha textures. Whenever you have a lot of alpha layers, somehow engine basically redraws the background scene again and again, I guess. I don't know how it works, but whenever we added alpha channels, alpha opacity, you know, materials that has alpha channels, that was causing a lot of problems. So if it's solid, it's good. If it has alpha channels, make sure it's small enough. It's not big, you know, big objects. So these are fine. But whenever you have an alpha image that basically covers a whole scene, that is a problem. And the last one is basically don't add HTML elements. Whenever you add that, I don't know how it works on browsers, but we see a little bit drop on performance as well. If it's possible, which is possible on Play Canvas, you can have all UI elements in Play Canvas, which is easier, and you can, you know, do a lot of animations without thinking about performance a lot. So this one also, the last one. Let me know if you know any other tricks for performance. Thanks for watching.